Good day! Are you one of those students that has difficulties in solving these probabilities? Well, me neither. Us. So, why don't you stay and watch this vlog? Because we can help you solve it. Let's go! So before we start, here are the terms to remember or the definition of terms. Probability is the study of randomness and uncertainty. Random, any activity which can be done repeatedly under similar conditions. Sample space, set of all possible outcomes in an experiment. Probability of an event, the ratio of the number of favorable outcomes to the number of possible outcomes. Random variable is a numerical quantity that is assigned to the outcome of an experiment. It is a variable that assumes numerical values associated with the events of an experiment. A random variable may be classified as discrete or continuous. Types of random variables: discrete and continuous. A discrete variable is a numerical value associated with the desired outcomes. It is also either a finite or infinite number of values but countable, such as whole numbers 0, 1, 2, 3. For example, the number of daily admissions in a hospital, the number of male athletes. Continuous variable has infinite numerical values associated with any interval on the number line system without any gaps or breaks. For example, height, weight, skull circumference.
Now, before we start, I will read first the word problem. There are 11 green marbles and 5 blue marbles in a jar. 3 marbles will be drawn in succession without replacement. Determine the values of the random variable g representing the number of green marbles might drawn. The first thing that we're going to do is to identify the possible outcomes and the value of the random variable. Based on the word problem, these are the possible values and the value of the random variable I have collected. Basically, the possible values of the random variable g are 0, 1, 2, and 3. Now, let's move on to the next step, which is the probability distribution. Here, we're just going to identify what are the probabilities that we might get a green marble, and we will base it on the result of the last thing that we've done before this one. First, there's a probability that we have 1 out of 8 or 1/8 chance that we're not getting a green marble. Next, we have 3 out of 8 or 3/8 chance of getting 1 green marble. Then, we also have 3 out of 8 or 3/8 chance of getting 2 green marbles. And lastly, we have 1 out of 8 or 1/8 chance of getting 3 green marbles. To check if the answer is correct, we must add all their probabilities and it must be equal to 1.
Now, after constructing the probability distribution, we are now going to represent it graphically by using a bar graph known as a histogram. So what is a probability histogram? Histogram is an approximate representation of the distribution of numerical data introduced by Carl Pearson. This kind of graph uses vertical bars to display quantitative data that is used in statistics. In order to make a histogram, first we need the probability distribution. Let's take another look at the data table. The first column shows the possible outcomes. Next to it was the probability of each possible value of the random variable. As we all know, bar graphs represent data with rectangular bars with heights of lengths proportional to the values that they represent. The heights of the bars indicate the frequencies of values in our datasheet. So with this, we can already construct a histogram. First, draw the x and y axes and label them as p of x and x of an event respectively. It is advisable to convert fractions into decimal for the values of p of x. For the x-axis, just write the possible values of the random variable in an event. Mark the p of x and x from the probability distribution. And lastly, draw a bar that corresponds with the value of the p of x and the random variable x. And that's how you make a histogram.
So, so in this problem, we're going to represent green as the capital G, while the capital B is representing the color of blue. In this problem, we're going to represent the green as the capital G, while capital B stands for the color of blue. Using probability distribution, we are going to find out what is the probability in distributing the color green. The given data shows the probability distribution of green. As you can see, in the chart we have 0 has a probability of 1 over 8 or 0.25. 1 has a probability of 3 over 8 or 0.375, which is similar to 2, which has 3 over 8 or 0.375 also. Number 3, we have 1 over 8 or 0.125. The answer to the given terms. The solution. So here is the solution, the given problem.
And now, we will proceed on how to get the variance and standard deviation. Since we already have this table, and we already get the mean, which is the 1.5, let's move to the next column. In this column, you will just square the previous column to get the answer. Negative 1.5 square is equal to 2.25. Negative 0.5 square is equal to 0.25. 0.5 square is equal to 0.25. And 1.5 square is equal to 2.25. Moving on to the last column, you will just multiply this column to its p of x. So 2.25 multiplied to 0.125, the answer is 0.28125. 0.25 multiplied to 0.375 is equal to 0.09375. And 0.25 multiplied to 0.375 is equal to 0.09375. And lastly, 2.25 multiplied to 0.125, the answer is 0.28125. And finally, to get the variance, you'll get the summation of quantity x minus the mean quantity squared times p of x. So this is the formula in order to get the variance. To get the answer, you'll be needing a calculator and add the data in the last column. And you'll be getting 0.75. And to get the standard deviation, you just to get the standard deviation, you will just square root the 0.75, and so the square root of 0.75 is equal to 0.866025 and that's how to get the variance and standard deviation. I hope you learned something, and thank you for watching this video.
Hi, good day to everyone. In this vlog, you will learn on how to get the variance and standard deviation. Without further ado, let's start. So, first things first, we need to define the variance and standard deviation. The term variance refers to a statistical measurement of the spread between numbers in a dataset. More specifically, variance measures how far each number in the set is from the mean, and thus from every other number in the set. While the standard deviation is the average amount of variability in your dataset, and it tells you on average how far each score lies from the mean.